Hi, we are here for a new video to show some nice features of eCam. This is again version 5 of eCam. And if you remember the first video of this set, it was focused in milling. Today we are showing some nice features of what we can call profiling because it's a 2D operation that can be done in several types of machines like a water jet machine, plasma cutter, um, or this type of 2D operating machines. Together with this type of operation, there are some very nice functions here to create nesting. And this is not very common for this type of package, software package, especially considering that eCam it's very cheap software when compared with the major uh, software brands that you have in the market. So this is the layout of eCam. You've seen it already in our first video for milling. And the first thing I will do now is to import a file which was prepared outside eCam. It could be done also here because we have some functionalities for geometries, but I've done it outside. I've created a DXF file and now I will import it. So open existing files. I call it shapes. In fact, this is the DXF. It's recognized as being a varicad file, but it's a DXF. So shapes, open. And as you can see, I have four shapes randomly inserted around here. I will not apply any transformation, so simply okay. And I have a couple of shapes. So a triangle, a circle, a square, and a rectangle. Nothing very fancy. We could have any other type of shapes. Now that I've imported my geometry, I will define a base plate to apply these geometries inside. We have three symbols for cam, turning, which will be the next video, the milling we've seen already, and today what we call here the generic cut. So new setup and simply apply a description. I will call it nesting. I can have several machine types. For this particular case, it's a cutting machine. And I could have different setups for the machine, which I don't have now. So simply accept what is defined. Okay. Also, on a similar way, like we've done it for milling, we need to define the base shape of the plate, and we have several possibilities. I will leave it a square. You can select also different materials. For the purpose, it's not important also. So I will leave in steel. I will simply define now the dimension. For example, a little bigger, 250 seems okay. 250 also. And thickness 3 millimeters. Now, as you can see, this is centered. I want to put the origin on this corner here to leave the profiles outside just for better clarity in the video. So X, Y, and Z offsets. X, I will put 125 minus, Y, the same, and okay. I think we are prepared to make something. So now that we have all the setup done, we go into this icon, creating nesting, and our first step is to inform the software about the shapes we want to consider. So part profile, and I will pick one by one. And we have part profiles. Another one, and another one. So we have recognized 4 profiles. So now we have a couple of conditions. We can change for sure the number of profiles, but let us see what we have here. So options, we can define a distance between each of the parts. We can create a couple of rotation count, which are possibilities to create the arrangement. I will leave this in the minimum number possible to take less time. And the nesting strategy, we have 3 available, and we will see the differences. Box, squeeze, and the gravity possibility. Result, after getting the options, we will get some informations on this tab here. So define geometry, I will say simply now, start nesting calculation. And the system will pick the shapes according to the strategy we have defined, in this particular case box, and will apply them, also considering an important information, which is the distance between parts. So I can stop the calculation when I'm satisfied, because it's keeping the calculation going to try to find other solutions, and it can take some time. So I will stop it, and I will make zoom to see that we have a little gap, which is the 1 millimeter defined in spacing. Let us try to play a little with this, saying, for example, instead of 1, saying 5, and starting again, and you will see that the arrangement, it is different. Okay. Now to see other options, let us try to create a little more shapes. For example, let us say 5 for each one of them. I'm not sure if they will fit all inside, but let us try. I'm inserting the same number, but we could have, for example, different numbers for each of the profiles, and start nesting. And okay, we have this arrangement. Stop. And now to see different possibilities, let us say squeeze or gravity. Okay, let us be a little more demanding with the program, and let us say, for example, here 8, 6, 5, 6, a little more parts. Let us give a little less gap between shapes and start nesting, and here we have. Okay, stop. So now about the results, we have a lot of results because we've done already a couple of interactions with the software. So there are a few options, and okay, here we have only one solution, and we can create this nesting for generic cutting machine, a milling machine, or only geometry. So we could export this as a geometry file. So generic cutting machine, create, and we should have this operation here, which can be simulated. So as you can see, we can do a simulation running. Okay, doing this a little faster, and we go. And also because you may understand that this is the final goal of, of the software and of this tool path, we can create from here G-code, choosing whatever we have and going to G-code. And okay, here we have our G-code for these profiles and this setup. So regarding the generic cut or 2D profiling associated with nesting, I think it's all. Um, I hope the video was clear on the correct way to work with the options, and I hope that you were able to see the possibility that we have with eCam, because these options are all included in a standard package for the software, and being very inexpensive, I think it's a great piece of software for all people and company that are looking for a non very expensive option for nesting besides all the other options.